Thank you very much. I'm going to try to make this brief so everybody can get to their lunch quicker. Let me just make sure I get my pointer working. Oh, beautiful. People don't usually associate rare earths with the Middle East, and I think we've got a very unique way to tie the two together here. So we're going to talk to you a little bit about how this region and rare earths go well together. Just quickly go through the company snapshot. We'll talk a little bit about the history of rare earth industry, pricing, how that's developed over the years. We're going to talk about our strategy to get to quick rare earth production in this region, and then we'll just summarize things for you here. Briefly, as a summary, we've been working the last 2.5 years to put together a strategy using a byproduct production to get to rare earth processing, and over the last year have focused on the region. Our company is founded by Dr. Bill Bird. He'll be in tonight and at our booth tomorrow. I welcome you to come by and meet him. He's a leader in the rare earth industry. Has been studying it academically and worked in it for more than 20 years. And we, a year ago, started working specifically in the region to bring a byproduct rare earth production strategy here. We've partnered with Takamo Investment Company and announced an MOU with them. They're an arm of Oman Oil. To bring a rare earth processing plant to their new industrial city of Dolkum, and we're just doing the studies for the analysis of that. We also have an MOU with Arab Mining Company, which is a pan-Arab mining investment company with an interest in developing it. We believe that there's an opportunity to build a rare earth value chain in the region here. The secret behind it is really simple metallurgy. Rare earths, as you may or may not know, one of the common things people say is they're not really that rare, and that's actually quite true. But finding them in significant quantities and in a way that they're easy to process is rare. So we've got a fast-track project methodology to make that happen here in the region. I'm going to give you a very quick history lesson here. China, for 30 years, has dominated the rare earth industry. And firstly, they dominate it because they've got the world's best geology in rare earths. Well, you can't be good geology for good mining opportunities. But what's happened over the last few years is the Chinese government, even though China has maybe 30 to 40% of the world's rare earth resources and produces 95% of the world's rare earths, it actually consumes 60% of the world's rare earths. So it now has determined that rare earths are significant for all of its value-added products in its entire manufacturing stream. So if you think about televisions, if you think about electronics, automobiles, everything that requires high-tech, that all has to do with the rare earth business. So China, as it's become an industrial powerhouse, has recognized that the downstream value of its rare earths are as or more important than the upstream value of just doing the mining and initial processing. So it's increased quotas, export taxes on it, and it's actually directed its state-owned enterprises to aggregate the industry together. That aggregation of the state industry in China, in effect, means they want to dominate it, but it's for internal use of these. It's not for the mining side of it here. So the rest of the world has kind of come out and responded to that. There's two projects, Molycorp and Lynas, that are looking to get to production in the short term, and many of the marginal explorers that are out there are going to have a lot of difficulty in this marketplace. This here is the pricing chart, probably the most interesting chart here, what one could ever imagine seeing in the commodity market. Now, people are used to certain commodities having volatile swings. You know, gold might swing $50 or $50 or $60 per ounce in a day or a week. This is dramatic, though. We're talking about, and this is the blended basket of rare earths as they're actually consumed in 2012. Rare earths are 17 different commodities, but you're sitting here in a sort of a low-cost marketplace where internal pricing and external pricing in China was about the same, maybe $10 per kilo as an average price here, zoomed all the way out up to $230 per kilogram outside of China in the bubble. The interesting things on this chart, notice this change here, that's when China decided to clamp down on its exports, and immediately the price outside China took off. This point here, where internally Chinese prices took off and externally they went parabolic, was actually, you probably recall the incident when the Japanese had a Chinese fishing trawler, and the fishermen, it kept them captive for a few days, and China threatened Japan with stopping rare earth exports. So that's when things kind of went ballistic on the pricing side. What's interesting here is it's kind of like a bit like the uranium bubble. It's come back down to earth. This band here is the long-term analyst estimates for rare earth prices, and the dotted line being the average price, and you can see it's almost fitting right into this number here. Interestingly, it's way off of its peaks, not surprising, but it's come off of its bottom, not surprising. The Japanese have run out of their stockpiles, and it's kind of on a bit of a inflation standard, kind of typically cost inflationary track as one would expect. So that's just sort of what's going on with the pricing. It's kind of back to normal, and marginal producers will not survive. Marginal projects will not get into production, but low-cost producers and low capex projects that make sense will get into production, and that's kind of what we're looking at doing here. So I mentioned that it was difficult to get into production. There's a lot of companies that would love to get their rare earth deposit into production, but the dirty secret, or one of the dirty secrets of the rare earth business, is there's significant metallurgical challenges. There's literally hundreds of minerals that have got rare earths within them, but there's only a very select few that have actually ever been successfully processed for the rare earths commercially. Also, high capital cost for mines, and we're not in a marketplace that high capital cost projects are going to win very well, and that's in a marketplace where there is insufficient funding. People talk about heavy rare earths. I'm going to mention that here. First of all, heavy rare earths there's less of them around, and they've got certain unique properties, like all rare earths do. China dominates this part of the marketplace and probably will forever because of the unique geological setting that heavy rare earths has in China. And there's really no magic bullet to get to significant heavy rare earth production outside of China. We believe monazite, which is widely available as a byproduct, and I've got a sample over there. I'm happy to show anybody who wants to come by. We believe monazite represents the best opportunity for significant rare earth production, and in particular, praseodymium and neodymium are a couple of important rare earth elements that are used in all the magnet materials, and those are essential, and really, from our perspective, are the things that are going to make our project more than economic. This is some of the uses of rare earths today and in the future, and projected sort of growth rates for them. As you can see, the uses are widely and varied, everything from high-tech ceramics, phosphors, glass additives, polishing compounds. It adds color to glass. It polishes glass and a whole bunch of other items. It's used in petroleum refining and cracking, auto catalysts, metal alloys, battery alloys, and the big one is magnets. The big wind turbines you see out would not operate without neodymium magnets. So, and they use a lot of it. Electric vehicles, hybrid vehicles are big users of it. The vibrator in your smartphone, vibration, that comes from a rare earth magnet. So all of those magnets are critical and are, as you can see, are the fastest growing area of rare earths. And as you can see in this long-term estimate, we've got about 110,000 tons per year of existing demand for rare earths, and projections are upwards of the 350,000. So the growth of the market is potentially enormous over the next number of years as further to the last presentation we saw from Ibn Ambro, the industrialization of the world, the use of high-tech technologies, be those phones and computers, automobiles, etc., really drive the use of rare earths. So that its market is growing at probably about double GDP growth rates. So what we're doing is we've got a fast-track approach for a high IRR project to develop rare earths for the Middle East. Have really shrunk down the development timeline by going after a byproduct approach with proven metallurgy. And we believe that the Middle East is a terrific place to do that. We've got a partnership with Takamul in Oman, as I mentioned, based on an MOU. The nice thing about it is we have a proximity to the source supply of monazite, which is in the Indian Ocean basin. Obviously, the industrialization of many of the Gulf countries and the encouragement of building industrial cities is terrific because it provides for good ports, infrastructure, obviously low-cost energy, and access to the chemicals that are important as well. This here's where we get our material from. So this is a picture of a heavy mineral sands mining operation in Mozambique. You can see it's near the ocean. There's the ocean in the background, and this is the beach, a large beach that is being mined, and you can see the dark mineralization here. That's the heavy mineral sands that is being mined for. So this is a large dredging operation here that's sucking up the beach sand. It is then separating the heavy material from the light material, and the heavy material in the heavy mineral sands mining operation is what's valuable, and that's the titanium and zircon minerals. That's what they're after. And what they throw back about in an operation like this, they might mine upwards of 20 million tons of beach sand per year. 95% of it, or 19 million tons, goes right back to the beach. They take the 1 million tons and put it into a mineral separation plant, at which point they take out the titanium and the zircon, which would typically be the key economic minerals, and they may end up left with, in a mining operation like this, with 5,000 or 10,000 tons of monazite left over. That's what we're after, that monazite, because that's about 50 to 60% rare earths. This is a breakdown of monazite. Monazite is a rare earth phosphate material. It's about 95, 96% light rare earths, and the balance is the heavy rare earths. As you can see, 50 to 60%. There's some slightly radioactive thorium, which must be sequestered afterwards or put into tailings ponds or spread out. There's different ways to deal with that. And then phosphate as well as a byproduct that can obviously go into the fertilizer business. This is a U.S. Geological Survey map of where the traditional or the large-scale monazite deposits are found, which is traditionally in the Indian Ocean basin, and many are associated with large, heavy mineral sand mining operations. And this is where we are working on sourcing our material from and looking to import it to Oman for processing. So we're convinced this is the right way to get to near-term rare earth production. Our target would be to produce about 10,000 tons of rare earth concentrate per year. That would represent about 8% of the global marketplace. We've accomplished a significant number of objectives over the last 18 months working on this project, and are very excited about our new partners in the Middle East to pursue this project in Oman. We really look at it as a kind of a two-phase approach here. The first one being the simple project, the first project in the phase one here, the output of which is a total rare earth concentrate. So all the rare earths combined that could be then separated by third parties. We could market that to the third parties. The second phase, larger phase, would be about a $250 million project, which would be then separating rare earths, and those could be delivered directly to the end user marketplace. We're fully committed to a safe operating facility. There's a slight radiological component to monazite, so that's got to be dealt with. We've commissioned an independent third-party group that went through this about 18 months ago, and obviously we'll be working with the environmental people in Oman on this, as well as obviously chemical processing needs a full environmental analysis. This is it's just sort of some of the overhead numbers of the project here for the individual phases. This material is available for discussion at our booth outside here, and this would be the phase 2 project. So the first phase would be about a $50 million project to create the rare earth concentrate. The second one, the $250 million project, which would then get you separating the full spectrum of light rare earths. We're very excited about this approach because it's really different than the traditional approach to get into production in rare earths outside of China. These two companies you may have heard of, these would be the leading non-Chinese rare earth production companies or getting to production. Molycorp, which is a traditional producer in Mountain Pass, California, and Lynas, a large Australian miner, and they have processing facilities in Malaysia. And then there's a whole series of other companies that are looking to get into production. So they've gone through the traditional, exploration, developing a resource, scoping work, metallurgical work, pilot plant, environmental, and are now some of them in the project finance or engineering procurement phases. You may be aware of some of these numbers, mostly Australian, Canadian, European companies. Medallion's taking a different approach where we did this monazite research with this byproduct material. Monazite's been processed for over 100 years for its rare earths, but once again, hasn't been done much of it over the last 30 years as the Chinese have dominated the market and are on a fast-track approach with our Middle East partnerships. We've got a top team of management people and technical people that we're moving forward with this project with, and happy to spend more time at our booth speaking with you on that. This is a preliminary timeline. If all goes according to plan, we would be into production sometime in 2016. That's it. Thank you very much.